So what may happen from time to time, I've seen it a lot in previous classes, for whatever reason, not so much this time round. When you create a toolbox part and then you save it to your directory and then you close your file and open up again on another computer, sometimes these parts can actually lose their defining features or their dimensions. So you may have set them up correctly, but all of a sudden in your assembly they'll be the totally wrong size. There's no way then to actually reconfigure them back to the same size. The only way to fix it is to remove them from your assembly and replace them with new parts. Now, if that hasn't happened to you, great. You know, it's something we don't have to worry about. You can see even here, I've just now when I'm pressing on these parts, in my feature tree, my part 8s have actually, the file name is reverted back to the original toolbox file name. That sort of thing, and the nuts now as well. So that's the sort of thing that can happen, which is a bit unexpected. So they're little things just to be aware of. And again, when we open up the toolbox and had a look at the first time round, we get this warning here about, while it's acceptable for a single user environment, is not recommended set up for multiple user, and that's what we're on, being on this network at RMIT. So we need to look at some alternatives just in case there was an issue. Now, most of you guys don't have to do these or submit these parts, but we're going to learn how to create our own nut and bolt just in case. So we'll start off with the bolt. So on my front plane, we're just going to try and make the same size bolt. I'm going to make first the threaded part. So it's a M10 bolt, which means 10mm diameter. And the one we made was 45mm long. So I make that 45. And then on the end of this face here, I'm going to do a hexagon. So I use the polygon sketch tool, 6-sided. And how this sketch tool works, basically you drag out, drop. It creates a circle construction line on the inside. You can dimension that, and that will give you the size or the outside size of the hexagon. So I'm just going to put in 15 for now. We can come back and define that later. And then just make one of these lines vertical or horizontal just to have it fully defined. And make the head size maybe 6mm. Okay, so there's a very rough example of the bolt there, hex head bolt. So just to add a bit more realism to it, we're going to add sort of a chamfered cut on the hex head itself, and we'll add a thread and a chamfer to that main cylinder area there. So first part is that chamfered cut. Now, we've done previously revolves, 360-degree revolve with the washer and the pivot pin and the pulley wheel. The tools that we use for creating by adding, be it the extruded boss, revolve boss, or the sweep or loft, you can also use those same tools to cut. So you've got extruded cut, which we know of, but there's also revolved cut, swept cut, and lofted cut. So in any shape where you can add material, you can also remove material from a shape using the similar tools. What we're going to do here is we're going to just chop off sort of the corner of these parts here around this hexagon head in a way that makes it look like it's got those neat rounded chamfered edges like a lot of these sort of fixings would have. So the geometry for this is a construction line down the middle, and then we're drawing this shape here, which I'll come back to and fully define later. So this is the shape that we're going to use to cut around that head of the bolt. I'm going to make this perpendicular and equal, those two lines. Okay, and then I'm just going to give them a dimension also give this line a dimension just so it's fully defined. So you can see how that sketch is set up. Now that sketch is set up on a plane which is going through one of these end lines, okay, one of those end points. If we had that plane, if we had this sketch on the right plane, it would be a totally different result, okay, because of the way the geometry is set up, and we'll see that in a second. So now I'll go revolve cut, and you can see the preview, and what's happening is it's revolving around, it's going to cut off these edges, but it's going to leave, you can see on the sides where it's round, it's going to go from sort of a large to a small cut. See the result? Okay. Now if you don't think the size is right, what you can do is click here and you can drag these numbers around. So I think it's the 7.5 affects how big or small that cut is. Okay, so if you wanted it to join all the way around, you could bring it in. If you want it to be separated faces, you drag it out. Round off the number, and there you go, nice little detail around that head. Okay. All right, the other one we're going to do is a thread, okay, down the length of this. Now, used to be that to do a thread, you would create a helix and spiral from this face, and you would go height and maybe revolutions. Okay, so you create the spiral. Now this would be a curve. All right, we haven't gotten to curves yet, but a curve is basically a line in space that you can then use for something like a sweep. So we haven't done much with a sweep yet, or a swept cut, but a sweep is where you have one shape that follows a path. So the curve is your path, and then you create the shape for the sweep. It might be a triangle or a circle to cut away material to create a thread. That's the old way of doing it. Now SOLIDWORKS pretty much has that tool built in. Under the Hole Wizard tool, there's a thread button. So here, there is a few settings in this. You start off by selecting the edge of the cylinder, and this is the starting point of your thread. So I'm going to start it from this end, and you can see the preview. All right, so if we go down, end condition, now we can go blind, or we can pick number of revolutions, or up to selection. So if we want to go all the way up to the end, we can select the end there. And it's just taken a while to preview, but it's going to calculate and go all the way to that face. Probably should change these first. The specification, where you've got your type and your size, is determining exactly what size the thread is. So typically, well, here we'd be doing metric, and there's the die, or there's the tap. So the die is where you're adding material, the tap is where you're tapping the hole, you're cutting away material. So I'm going to go metric, and I'm going to start with metric die, change that to M10. All right, now we get a bit of a preview. I'm going to change this end condition and go blind, and just change it to about 42 mil so it doesn't go all the way to the end. So you've got tap and die, so they're two different things. Cut thread or extrude thread. So if we're cutting away material, it's a cut thread. Extruding is adding. And then you've got some other throw options, right-handed or left-handed. And the size here, where there's M10 by 1, that 1 mil is the pitch. Okay, so the distance between each of the threads. So cut thread. Okay, so that cuts away from that N10 size. Now I'm just going to change some of the settings. Okay, so there's a thread. Now it's not a perfect replica of a real bolt because these would smooth off at those ends, and that might smooth off at this end here, but you can do something like a sketch on that face, convert entities to convert those edges, and then extruded cut that goes through all. Okay, that just sort of neatens that edge off. And another thing you can do is add a chamfer to this bottom face. Not that edge. That edge on the bottom. Okay, and there's your bolt. Now, to do a nut that would be matching this, you could save this and save a copy, and then just delete, you know, the thread and the cut extrude and the chamfer here, and then just change it to a hole on the inside and do a thread on the inside as well. So you could do a matching part very quickly. So that's how you can create simple parts like that. The other thing I'm going to show you is a website. It's called McMaster Car, and they're a supply company. And they have all sorts of fasteners and pipe, tubing, hose fittings, power, transmission, sealing things like O-rings, temp control, filtering, electrical, lighting, a lot of different products. Okay, things that you can sort of buy off the shelf. I think you can pretty much, anything that's on this website you can actually order. So if you were designing a prototype, you could go here, find your part and order it from them. It's a US supplier, so you'd have to look through that. However, the main thing which makes this website awesome is that it has 3D files for everything. So I can click here to hex head screws and click on hex head screws here and pick the type that I like, steel hex head screws, and I can see a lot of different finishes. I can go system of measurement, metric, and I'm just going to pick on the first one here. And here are your sizes. So M6, M8, M10, fully threaded or partially threaded. So we've got M, and that's the pitch, M10 by 1.5 mil. So I'm going to click on fully threaded, and if you click on the number here, click on product detail, CAID, it shows you some specs. On the top right, it shows you the options for downloading a file. So you can download 2D or 3D file, you can download a SolidWorks file. Save. It'll just ask you to save that file. And so long as it's not made in a newer version, there's your part. That's it. Pretty easy.
So for our assignment, we've probably all got the library files in there.
So the ones, unless we've
had any problems, we're right.
Yep,
to just
that's right. Exactly. Yep. You don't have to change anything.
Yep.
But yep.
And there's a few, like, we could have chosen different bolts or nuts or things.
Yeah,
like,
any
not-
one
not
that's
a
the
big
right
deal as long as
size.
it- yeah.
As long as it's the right size, it's
Yeah.
fine. That's
Cool.
right, yeah. The thing I just want to point out with these, like, you now know of this website, you probably never need to model a part again, you know, if you're looking for a nut or bolt or something else like that. However, if you were, you could always download something like this or open up something from the toolbox and actually see how they're modeled, you know, and actually see the dimensions that are used. So, you know, this, if you're trying to remodel something like this from scratch for whatever reason, let's say you couldn't open the file, you could download the drawings and then remodel it. Okay, so it always pays. There's nothing wrong with, you know, just downloading those files to have a look at the way in which they're built, the steps that are taken. So this is done with a helix and spiral, as you can see there. Chamfer on the end. And this is done without that thread tool, but with a cut sweep. Okay. It does give you a little bit of a different result. And they do this shape here with a cut extrude. All right, they've done it in a different way. So that cut extrude is done by having a circle, going through all, flip side to cut, which cuts on the outside of the circle, but then it's also got a draft angle. So it goes out at a really sharp angle, and that's how it's done that shape. So we mention it regularly, but there's always different ways of modelling. Okay. Did anyone have any questions about any of the parts, any of the features or dimensions or things they need to change? Keeping in mind that what you see on screen, mine is not perfect. I haven't updated all my dimensions or anything there.
Just how to save the fasteners into my folder. They're
So,
listed like yours.
These ones?
Yeah.
Yeah, so even though, like right now, mine have sort of lost their file name,
Yeah.
if I've already got them in my folder here, part 8 and part 9, I don't need to resave them. But if you did, all you do is go File, Open, and it's going to open them as read only, which is fine.
Yeah.
And you just go File, Save As, and go to your folder, and you can just save over the top of the ones you've already got there.
Sure.
Okay. Alright, and that will rename them here in your assembly file as well. Any other questions? Okay. Well, that's really good. Alright, so what we will go over now then is the file referencing, SOLIDWORKS references file management part of the project. Right, so this is the part where you want to get all your file names correct and make sure that when it comes to submission, everything will be there. And we're going to look at it, we're going to sort of do half now and half later. We'll look at another option just before submission. Right now I'm going to teach you the fundamentals of it. Okay, and so what happens with your files. So, to show you the incorrect way of doing things, I'm just going to change the name of some of my files here. Just to show you what happens when you do things without letting SOLIDWORKS know that you've changed parts. Okay. So what I've done is I've just renamed them in Explorer, Windows Explorer. When you open your files, or when you create an assembly, every file that you add to that assembly has a reference. It's referencing back to its location on your drive, or someone else's drive, or USB, or whatever, and what that file name is. So when you save your assembly, it remembers all that information. So next time you open the assembly, it looks for those files. In this way, you can open up those files, or someone else can work on them, and then later on you can open up the assembly and the assembly will update based on those changes that have happened. If you change those files without telling SOLIDWORKS where they are, this is what's going to happen when you open up your assembly. All right? You browse, suppress, or suppress all missing. Now, suppress is like turning it off. So, talked about suppress on and off before. Suppress will turn your part off. So, if you submit and you haven't checked your assembly and you've just changed the file names through Windows Explorer, when I download it and open it, this is what I'm going to get, for instance. Okay, missing parts. Now, you might still have all your parts in your folder here, but if they're not named correctly, as far as the assembly goes, it's not going to be able to find them. To fix it, if something goes wrong, okay, you can unsuppress and it'll ask you to locate it. All right, so if you know what it is, you can go browse, you can find it, press open. Okay, now I've got the same thing because I renamed some of the parts. I've got the same issue. Again, I have to browse, identify the part, press open. Now what happens if you identify the incorrect part? You'll get a warning. The reference document has a non-matching internal ID. So all these parts, even though you name them certain things, they've got an internal ID that SOLIDWORKS uses to recognize them. So it can recognize when you've selected a file with a different name, which actually doesn't match what the original was. Okay? So that's a warning. Sometimes you might be doing that on purpose, replacing one file with another, right? But this is just saying, you know, use this one anyway, or keep it suppressed, or try again. So I'm going to open that subassembly and try again with that part 4. Browse, form bracket, open, and unsuppress. Okay. All right, so that's how not to rename your files. So the low-tech way of renaming them is very simple. Any file that is referenced, okay, let's say from your assembly. All right, so this part here, the washer, PO2, the washer is referenced in this subassembly file, which means I want to have this subassembly file open, either in the general assembly or on its own. Then I can open up this part and I can go File, Save As. Now, this window here that pops up is talking about those references. So it's being referenced in Open Documents. If I want to save a copy, I can do that, and that won't change the reference of the existing part. All right, and so I can save a copy, continue working, or save a copy and open. If I want to change the name, then I click Save As, and I can go back to what the original was, PO2. Save. So that renames this file, and it also updates the reference in my assembly here. Right, so it does the hard work for us, updating all those references. So I'll do the same for the form bracket, just to get that back to what it was. And then the subassembly itself, same thing. All right, so whether it's a part or assembly, it's the same thing the way the references work. Save, close. All right, so now I've got all those names back. If you ever see, and some people mentioned this already, when you might explode and collapse, it looks like you've lost all your mates or that's not fully defined. What you have to do is just rebuild. Now sometimes you can see this icon here, these traffic lights, green and red, at the top of the screen here. They're there as well. So it's the rebuild icon. You can press that to rebuild, or Control Q will rebuild your assembly, and then it will just refresh and fix up those. You'll also notice I've done that again and I've lost that nut and bolt again, P8 and P09. So that might be something that I'm not able to fix. So that's the way for you guys to rename your files. There is another way of doing it, which we will do before submission, which is in the pack and go part of the project. However, when you do pack and go, the one thing that you can't do with your files, which you can do when you do save as, is add a description. All right, so this, having your file named correct and the description added in here is part of the assessment. If you don't have that description in, you'll lose some marks. All right, so I want you to go through each of the parts, rename them, make sure that description is in there. I'll show you the pack and go before we do the submission. The other thing I'll show you quickly now is with those nuts and bolts, okay, they've lost their references again. Something you can actually do within your assemblies, if you already have a copy of a part or you want to change the references of parts in a way. So I have in my folder here part 8 and part 9, which are named correctly. All the dimensions are correct. I want to put that in my assembly without having to delete this one and remake everything. What I can do is right click on that part, click on that drop down arrow and press replace components. And if it's not open, I can browse for the file, but it's open there. And there's 2 of them, so I'll go all instances and go OK. So long as the faces and details that are being used for mates and other features match up, it will replace them. If they don't match up, it'll just give you some question marks here and you can match them up manually or delete the existing mates. But that all works because obviously they're the same part. I press the tick and you can see that's now been replaced with a part 8. All right, so I'll do the same here. If this keeps happening to you, I'm not too worried about the nut and bolt if they don't have the correct names when I open your submissions. All right, so just keep that in mind. I won't be too stressed about that. Okay, and save. All right, and that's so that's how you can get your naming correct there for all the files. All right, so first step. I've got just for checking, this is my folder and I've got 9 parts. 9 parts and 2 assemblies, all right? And so 11 files, and that's essentially what your zip folder should look like when we're finished, okay? So that's just our reference point. So I'm going to open up Blackboard and log in, and you need to do the same if you haven't already, because that's where the submission happens. If there's no internet access, then that'd be great. Nice. Alright, so at this stage, I'm going to assume that you've read the brief and you know what you need to submit and the format that I requested. If you're not sure, it tells you everything here. So Project 1 submission, which I'll make available now, so you'll be able to see it. It's today, 8th. Available. Right, so under assignments and Project 1, you'll see here Project 1 submission. You can click on that and it'll come up with this screen, and this is where we actually do the submission. All right, let me know. I think some people can see it already. Yep, so that's good. All right, so with our file, what we're going to do is create a pack and go. So a pack and go is something that you export from SolidWorks and basically zips everything together, keeps all the references together, and it makes it really easy for you to send files to someone else. It might be to a supplier or to a client, or I often use it at work, or it gets used in workplaces a lot for creating copies or backups. All right, so you get to a point where, okay, you want to make a whole new version of everything. You don't just copy and paste it in Explorer, because as we talked about with references before, that assembly might still be referencing the old files, all right, rather than the new ones. When you use the pack and go feature, it updates all the references for you. So pack and go is found under File, Pack and Go, and that's going to open up this pop-up. So just to explain, there's a few tick boxes up the top. If you've done a lot of work with your files, let's say you've created drawings, done some simulation, or included decals or appearances, you can check those boxes and it will include all of those other files when you're creating your pack and go. In our case, we haven't done any of that stuff, so it's specifically just the parts.
Notice that part 8 and 9 aren't there.
That's right, part 8 and 9 aren't there because I've used toolbox components, so I need to check the box that says include toolbox components. And now I should see that down the bottom I've got 2 assemblies and 9 parts. So this is the other location where you can rename files. All right, so when you're doing the pack and go, if you wanted to you're doing, let's say, a copy of your files, and I wanted to change this General Assembly 1 to number 2, I can click in this box here and click on this text and change it, and it will change that name to green, which is indicating it's renaming the file. Now, I don't want you to do that, but that is how it works there.
Can we delete the bolts?
Yeah, you can rename them. So that's a good example. If your nuts and bolts have sort of renamed themselves, they're one that you can just change to part 08 or part 09 here. Down the bottom, it's got save to folder. That's what you would use if you're just making a copy. What we're doing is we're going to put it in a zip folder, so it's ready to email or upload. So you check the box here, save to zip file, and press browse, and with that you can pick the location for where it's going to save. So I'm going to save that in the same folder with my other files. And if you were saving it for, a client you were emailing, or someone you were sending it to, you would give it a proper name. I'm not too worried about that here, because when you submit via the Blackboard, everything's stamped with your file, your student number anyway. Okay, so you don't have to worry about it too much. Just name it pulley files if you want, and press save. When you're happy with all that, press save, and you can see down the bottom it's updating references, okay, compressing those files together, cleaning it up. Now in our folder where we've saved it, we should see there's a zip folder there. Okay. So what I'm going to do, close all of the files that I've got open, and double click on that zip file. So inside the zip file I can see the compressed files. Right? Before we submit, or before you submit, or before you email it to your boss, or to a client, or to your supplier, it's a good idea to actually check your files. Make sure that what's in there works, there's no issues. To do that, you have to unzip the files. All right? You can't open an assembly from a zipped folder because it won't be able to find all the references properly. So, on your desktop, create a test folder. Just name it test, and open that. And from your zip file, select those files and just copy them into that test folder. Now, for whatever reason, I've seen this a few times, the copy paste or the exporting works really slowly. You can see it hasn't copied all my files across. But just make sure you get them all out. All into that folder. Yeah, I don't know. Okay. Once you've got them all in that test folder, open up your General Assembly to check that all your file naming, all your references are updated properly and that you've got no problems. If that opens fine with no issues, then you know that that zip file you've got is ready to submit. If you've got issues, then you can go back and address them, do your pack and go again if you need to, until you're ready to do the submission. Right, so that's worked. So I can delete my test folder and go back to my folder with my zip file. It's here. So now on the blackboard, so what we're doing, where it says assignment submission, you browse computer to find your file, and you select that zip file and press open, and that's going to attach it. Your self-reflection, which you would have typed up somewhere, copy that, paste it into the comments section here. So don't add it as a text submission, just add it to the comments.
Just the body of it.
Yep.
Does it include student number or
Sorry?
include student number?
No, no need. It's all stamped as you, so there can be no mistaking. And when you've done that, hit submit. That's it. Okay, so you've got your zip file there. You've got your self-reflection in the comments. Hit the submit button, and then across the top of the screen, I think it should come up with a green bar saying project submitted, and that's it. Cool. Now, for your reference, I'm just going to show you what this rubric is here. Okay, so if you see click on the assignment, you see the view rubric button. This is how I grade your projects. So what I'll be doing over the next couple of weeks is I'll download your project, unzip it, put it in a test folder, open it in SolidWorks, go through all your parts, have a look at all the criteria that I've got noted here. So this is the criteria that was on the original brief, is the same one listed there in the assignment information. And this breaks up the weighting and the grading for each section of the project. So NN, anything below 50% is NN. So then you've got 50 to 59 pass, 60 to 69 credit, 70 to 79 distinction, 80 above HD. So I'll go through and I'll, once I've got an idea of what your stuff's worth, I'll basically tick a number in each of those boxes. It'll add up your final score. I'll also add some comments. So I might say, yep, your mates are perfect, or you had some dimensions wrong in part 2, 3, 4. Okay? And then an overall comment at the end. As soon as I've graded it and hit submit, you'll be able to view your grades. Okay, so you'll be able to see them through your My RMIT, I think it's through View Results or something like that. You'll be able to see it, and I think you have to click on View Rubric to see the comments. Okay, so this is the main way that I provide feedback for the projects. If you want further feedback after that, then you have to speak to me during class or after class or email me. Okay. Okay, so first up, this time when we're starting a file, we're starting with a 2D drawing file. So select drawing, press OK. And it'll come up with this sheet format / size pop-up. So the other thing to explain here with drawings is there's sheet formats and there's file templates. Right? So it can be confusing, so I'll try and keep it as simple as possible. When you start a part file, that file that opens up is opened up from a template file. Okay. Now that template file can be set with units of measurement, like millimeters or inches. It can also be set with things like materials or information, like who's editing the file or what company you're from. Okay. Same thing with assemblies and same thing with drawings. Okay. When you open a file, you're opening up a file template. When I open up this drawing template file, there's no sheet format. So the sheet format is specific to the drawings, and you can have a different sheet format for every page, although you wouldn't do that. Typically you have one sheet format for that whole set of drawings. So when we looked at those examples that I showed on screen, there was one sheet format that went across every single page of those drawings. Okay. So what this is asking us to do now, when we open up this drawing template file, there's no sheet format associated with it, so we have to pick one. So typically, industrial designer drawings will be A3 size. Now, that doesn't mean to say if you're working on a project and you're doing something for the workshop and you want to print out something one-to-one, there's nothing stopping you doing AO drawing and having a big one-to-one printout. All right, but typically, if you're doing a product design sort of project for communicating or printing, even printing PDFs or sending, you just do it at A3 size. So uncheck that box that says only show standard formats, and you'll see there's a lot of other formats built in to SolidWorks. And there's some at different sizes and there's some at different standards. So you've got like ISO, you've got DIN, GOST. I don't know a lot of those mean, but they're just different formats. Just pick on one, any one really, it doesn't really matter. I'm gonna go A3 ISO and go OK. All right, and when you start your drawing, the first thing it's going to ask you to do is insert a model, because that's what it wants you typically want to do. You want to start your model view, all right? But we're not going to start, we're just going to play around and have a look at the drawing template first. So just press the cross there. So the background of your page, that's the sheet format. All right. Now, when we get to next week, when we have, I will supply you with the updated sheet formats. We'll be able to load those in, okay? And we'll look at how to edit and how to add information in those sheet formats at that stage. Sheet formats, how they carry across the pages. You see at the bottom of the screen it says sheet 1, and next to that there's an add sheet button. If you click add sheet, it's going to add another sheet, and that has the same sheet format. When you create your pulley drawings, your whole drawing set is in one file. So eventually down the bottom you'll have maybe 10, 11 or 12 sheets. Is everyone clear on that?
Yeah.
All right. I'm only going to say this once. Someone will do one file per drawing, and at the end of the project they'll be like, how do I combine all these together? And I'll be like, you can't. All right, so don't be that person, okay? It all goes in one file. Now, the reason for that, there's a couple of reasons. The first reason is that the sheet format, that has information that carries across all the pages. So when you update something like the project title, or it might be the date, or it might be someone that's approved or checked your drawings, it'll go across all those drawings. If you've got separate files, then you need to update every file individually. All right, it doesn't carry across. The other reason is that when you want to export this, you can just go File, Print. Okay, if you're like printing or printing a PDF file, you just do it from one file, combine it all into one file for you. If you've got 11 different files, you have to do that 11 times to get your drawing set. Okay, so that's the reason we typically do it all together. Now, sheets on the bottom, you can add and you can click them and you can move them, you can drag them, you can right click on them and rename and delete, and you can copy paste. You can do the same thing on the side of the screen where you can see the sheets and you can right click and go delete, copy or paste as well. So just right click on sheet 1 and click on properties, and this will open up a little bit more information. So first thing here is you've got your scale 1 to 1. It's also in the bottom of the screen. All right, you'll see it there, 1 to 1. When you have a drawing view added in, okay, you can actually change the scale of the sheet by clicking on that on the page. For our pulley drawings, it's going to vary page to page because some of our parts are really small. You wouldn't have them 1 to 1 because they'd be so tiny. All right, so parts like the washer and the bush, you might make them 5 to 1 instead. All right, we'll get into that side of things when we get to those parts a bit later. Type of projection, that affects how your drawing views will react when you do something like a standard 3 view, which has a front, top and side view. Okay, the type of projection differs for different industries, so or different types of design. So I think architects use first angle. Okay, landscape architects use first angle. Product designers, industrial designers, third angle projection. Have to go back to Year 12 graphics for me to try and remember the reason why. You can look it up if you want, but typically your drawing should be on third angle projection. If you ever wanted to change your sheet format, you can do it here. So you can browse for a new one or reload if you've made any changes to it. We'll do that next week. Otherwise, there's not much else you need to play around with here. So you can press cancel or OK. So the sheet format, just to explain quickly again, that is in the background of your page. So you can't edit any of those lines. Any drawing or lines you add on the top are things that you can edit. We'll look at how to edit the sheet format next week. So we're going to start with our general assembly. So what I'd like you to do actually is to close that file, start a new drawing, but this time when it asks you to select a drawing format, select custom sheet size and just make sure it's A3 size, 420 by 297, and press OK. And that will create a blank page for you. So if you want to create a blank drawing, you want to add something to the drawing, just print it off on paper, you can do it that way. All right? So we're going to create our drawings with a blank format, and then we're going to add the format later. Okay, so your command manager at the top's got some different buttons now for drawings. So you can see standard 3 view and model view are the two main ones that we use. So click standard 3 view, click browse, and then browse for your general assembly file and press open. And you should see it pop up on screen. So, a couple of things. What's funny?
Oh, mine's just like yours is proportionally smaller than everyone else's.
That's okay. So, a couple of things. First thing, when you import a drawing view, first view to the page, SolidWorks will rescale your sheet format to suit. So if you picked another part, okay, like a smaller part, it might have made the part a different scale. So even though this sheet would have started at 1 to 1, it's now 1 to 2. You can see that in the bottom right of the screen. If you click on that, change it to 1 to 1, and to get everything up to 1 to 1 size. Okay. So when you create a standard 3 view, it's got a front view, a side view, and a top view. Now that front view is based on your assembly. So if you're in your assembly and you're looking at the front view, that's exactly what you see here. Okay. So if yours looks like it's a different angle, well, it might be a different angle in the assembly, right? That's okay. One of the things that you can do, let's say you had yours facing sideways instead of facing the front, click on that drawing view, okay? So you see that blue box or the orange box, click on the front view, and on the left of the screen you can see the drawing view properties, and under orientation you can click one of these other views to change, press yes, all 3 of those views. Alright, so when you create a standard 3 view, it creates this front view, and then these other 2 views are projected views. So a projected view is a view that's gone off at a 90-degree angle to your first one. So looking at 90 degrees from the side, 90 degrees from the rear, 90 degrees from the top. All right, so with these drawing views, you see they've got these boxes around them. So those boxes are used for selecting them and moving them around. So if you go to that top view and hover over it and click, you can drag it, but you can only drag it straight up or down, okay, because it's aligned with that front view. If you want to break that alignment and move that elsewhere on the page, you right click on that drawing view box, press alignment, break alignment, and then you're able to click and drag that view elsewhere. If you want to reset the alignment, right click on that drawing view again, alignment, and default alignment, and it will take it back. Okay, the other type of views, you can see now that we've got views on the page, all the other buttons are open now. So projected view, auxiliary, section detail, break, crop, and alternate position view, they're all options now. The ones you typically use are projected view, section, and detail view. So we'll have a look at those as we go. So the other thing that we want to add to our first page of our assembly drawings is a 3D view. All right, so an isometric view. So there's 2 ways of doing that. The first is to add an individual model view. So click model view, double click on the assembly, and then with your view options here, select isometric, and just drop it on the page. You get your isometric view up in the corner. So that's one way of adding an isometric view. The other way is using the projected view button. So click projected view. Now, just before you do that, make sure you haven't got any view selected. So just press escape, then hit projected view, then select this front view drawing. And then with projected view, what you do is move your cursor out on an angle. So how projected views work, wherever you move your cursor, it's going to create a drawing view. All right, so you can move it out on an angle and you'll get an isometric view. All right, so we've got a couple of views there to compare now. So I'll just show you some of the settings. So I'm going to select that front view. So on the left of the screen on the drawing view properties, up there's a box that says show in exploded or model break state. We'll look at that later on. That's how you can create an exploded view. But we can ignore that for now. Come down a bit and you can see there's display style. So the default is hidden lines removed, but the alternatives are hidden lines visible, hidden lines or wireframe, shaded with edges, and then shaded without edges. And what you'll notice, as I change those display styles, these other views, well, 3 of the other views have changed with it. Right? What this is, in SolidWorks terms, they call it a parent and child relationship. So this is the parent view, and this is the child view. So the child view is linked to the parent one. That just makes it easy to control things like scale, things like the display style, like we can see now. Instead of having to change everyone individually, you can just change one and it'll do it as a group. But saying that, you can have the children to be separate. So if I want this view here, this 3D isometric view, to be different, I can just go here to display style and click hidden lines removed. Okay, and that will revert back. If you guys have any questions at any stage, feel free to yell out as well. So typically in our drawings, keep it as the default, hidden lines removed. You can see the same thing there with scale. So at the moment, these drawing views are using the sheet scale. So our sheet scale is set at 1:1, so these drawings are 1:1. If I click on this smaller drawing, you'll see that that is using a custom scale. Now, SolidWorks just did that manually for us. It'll do that if it thinks it's going to be hard for you to fit the drawing view on the page. If I want to turn that back to 1:1, I just press here, use sheet scale, and then I'll go back to 1:1. So typically on your drawing, you want to have everything at the same scale on that one page. In your sheet format, there will be an area that says the scale of the page. Okay, so you don't want to have that scale saying one thing and your drawing views being at another scale, unless that drawing view has a label with it that's saying this drawing view is scale 1:2. Okay, it would just, we'll look at how that works later. The other details in these options here, dimension type and cosmetic thread display, we never use those, so you can minimize those. The main ones are display style and scale. Now, with drawing views on a page, you can select and move them around. If you don't want a view, you can click it and press delete on your keyboard to remove it. So our general assembly page is going to have 4 views like this, front, top and side. We'll revert this one back. So just change this one back to the front view as well. So the general assembly page is going to be pretty straightforward. We're going to add some dimensions and view labels to it as well, but we're going to leave that from this page today. We'll do that next time. So let's add another page. So click Add Sheet. On this page, we're going to do a exploded view. So this time, just press Model View and browse to your file or click General Assembly. You can always just drop the view on the page and then go back and change the view orientation later. So click on Isometric View, click on 1:1 for the page, and then to make it an exploded view, in your view properties at the top left, tick the box that says Show an exploded or model break state. And that'll show you your exploded view. Right, so your task for this project, and it's a little bit difficult because we don't have the sheet format yet, but to give you an idea, the sheet format border is going to be something like this. All right. So those lines that I've just drawn, our sheet format's going to be around the bottom, okay? So your task is to create an exploded view, which is going to sit in that area at 1:1 with no parts overlapping. Okay, so you can see on mine, I've got pretty good clearance around everything except here. So I need to go back, edit the exploded view, and just spread those parts out a little bit more. There are some different tools though that you can use to help with that sort of thing. And one of those I'll look at now. So I'm going to open the assembly. So one of the good things with the drawings is you can click on any part in the drawings. Like let's say I click on this pulley wheel here, right click, and I can click here, open part, and that's going to take me to that part file and I can edit it. All right, Control Tab back to the drawing. I'm going to open the assembly file and edit the explode view. So edit feature on the exploded view. Now, sometimes our sheet format's going to be pretty minimal. Okay, so we've got a little room on the page, but sometimes you won't have as much room. So you need to be very specific about the angle of view that you're going to show in your drawings. So instead of having a 45-degree angle, which is what the isometric is, it might be better for us to have something that's a bit more level. Okay, I don't want a front-on view like this. I still want it to be 3D. But what I can do is go to this front-on view, use my arrow keys, just a couple of times, around at the side, and then maybe once or twice down. Okay, something like that to get a view like this. Okay, it's not as great an angle. I can hit the space bar, and with my orientation pop-up, I can press here, new view, and I can name a view. So I'm going to name this as exploded view, and OK. So if I click on isometric view, that's the isometric view there. But what happens if I rotate around, I press the space bar, I can see that that exploded view is saved within the file. I can go back to it here. I can edit my steps. I might just have to drag those out a bit more there. Okay, so I'm happy with that angle. Press the tick on the exploded view. I'm just going to save, Control S. Go back to my drawing. I can click on this drawing view, and in the properties on the left, that exploded view is there, and I can hit that checkbox, and that's going to change the angle of my drawing to match that view that we were just editing. All right, and that shape or that angle is going to fit a lot better on my page. All right. So I'm just going to leave it there for now. Have a play around. Okay, your aim is to try and get an exploded view, something like that. All right. Once you've done that, just have a play around with the other tools, see what's there. We'll touch on a few things before the end of class. But yeah, just give that a go. So with those exploded views, the one thing that I didn't show previously is the ability to add route lines to these. So route lines are little sketch lines that connect each of the parts that show the path that they would take to assemble. To add those, you need to be in the exploded view. You don't have to be editing it, but just have your assembly exploded. Up the top next to the exploded view button is the one here that says explode line sketch. So you can select explode line sketch, and then it's as simple as just connecting your items. So I'm going to start here. Now you want to try and select a flat or a round surface. So I'm going to select this inside face here, and see that arrow? I'm going to flip the direction of the arrow so it's pointing the other way. And then I'm just going to select each of these holes. So select the holes rather than the edges, and it's going to create like a little line up, okay, to go through the form bracket, and then one down to come through the bush on this side. Now, if your parts are all in a line, you can just select, you can sort of skip parts, you know, and do the same thing. Now, once you've selected all of the parts that you want in one line, hit the tick, and it creates that line for you. Okay. Now, if you've stuffed up, you can select it and delete it, all right? Or if you're okay, you want to continue, you can select the next one. Now this time, this one just goes straight all the way through, so I'm just going to go end to end and okay. And then do one for the sub-assembly as well. All right, when you're happy, press the tick. So that's actually a 3D sketch. So it's currently in sketch mode. Just press accept on the sketch. And then you can collapse your part. So when you collapse it, the line disappears, but the line will be there when you explode it again. I'm just going to save. Control Tab to my drawings, and you can see that line's updated now in my exploded view drawing. The last thing we're going to look at today on a new sheet is section views and how to add a bill of materials and do some balloons. So this sort of wraps up, some of the really basic assembly functions. So for this one, we'll just do a model view, and we're going to make that model view a side view, so either left or right, and make it 1-to-1. And up the top, we're going to use the section view tool. So select section view, then have the cutting line going vertically. Now when we drop our section line, we don't want to just drop it randomly. We want to try and snap it to something that's on, where we want to cut through our part. So if we want to cut right through the middle, we can hover over the center of one of these fixings or one of these lines here to get like a center point. Drop, press the tick. We can tick auto hatching, press OK. And then you drag your cursor to one side, and that creates the section view. So what the auto hatching does is it changes the direction of the hatching for each of the parts. It's not always the most clear, as you can see between the nut here and the reinforcing plate, right? But it is better than everything being the same direction. All right, so the section view, how that works, it's cut a line through the model, and it's basically showing all the parts here. And if I turn hatching on, they'll be hatched in different directions. If you press slice section, it'll just hide anything that isn't on that line that you've cut through. And flip direction, that will change the angle of, or which way that section view is facing, whether it's one side or the other. For this section view, that won't make a difference, apart from flipping the nuts and bolts, right? But on other section views, it can make a big difference which way you're facing, how that drawing view is going to look. What we want to add on this page is a bill of materials. Now to do that, that's under annotation tables. So we're going to go tables, bill of materials, and what you have to do is select a drawing view to specify the model. So you can select either of these drawing views, and there's a lot of properties for this bill of materials on the left, but we'll just stick with what's there, press the tick, and that's going to create this table here. So I'm just going to drop that on the page, and then we can have a look at some of those settings. So you can click on that bill of materials again, and then on the left you can edit those settings. So at the moment it's top level only. What top level only means is it's got the sub-assembly, it's got the other parts, including the nut and bolt. The parts that are in the sub-assembly aren't shown, because we're only showing the top level. If we show the parts only, then it's going to break down that sub-assembly and it's going to show the parts, individual parts that are inside that subassembly. Indented will show both, so they'll show the subassembly and the parts. So it just depends on the way you want to communicate. For this project, you will have a page like this for the general assembly, and then you'll have a similar page for the subassembly. So that means on this page, we can stick top level only, because on the subassembly page, it will show what parts are in the subassembly. The other settings there, you can play around with them if you want, with the border or the internal lines, but really there's no need. When we have a sheet format, we're able to snap this bill of materials table to one of the corners of the sheet format if there's something there, if there's a border there. But for now you can ignore that. That table can be sort of formatted, so when you hover over it you can see a corner come up the bottom right. You can click and drag, okay, and that will resize. The other thing you probably would have noticed here is my Part 8 and Part 9, they've lost their file name here. So the information in this bill of materials is generated from the details in your files. So they're the file names that I've saved each of the parts, except for these ones here. All right, and again we can see we've got that issue in my general assembly. You know, those files have lost their part names again. So if this is something that keeps happening, this is a point where I might want to create, or download one of those McMaster files. Okay, save that as Part 8 and Part 9, insert them into the assembly so that I don't have this issue ongoing with it losing its name every 10 minutes. Right, so you may want to do that at some stage if you've got that problem. The description you can see here, they're those descriptions that we've added into our files when we save them as well. So if you haven't, when you do your bill of materials and there's no descriptions here, it means you haven't added them when you've saved those files. So to add them, what you need to do is open up the part, go File, Save As, name your part and add the description in here, save. When you go back to your drawing and press Rebuild, that'll update here in the description. So this bill of materials is pretty basic, just showing part number and description, but you can always right click and insert more columns, and those columns can be linked to other properties, and those other properties can be linked to certain things in your files. So it's getting into a bit more advanced stuff, but each of these files can have specific properties added to them, like material type or finish, or it might be their supplier or how much it costs. Right? So you can have a bill of materials that has as much information as you want to add in. All right. In our project, what we will do, and we'll do this in a later week, is we will add a column here for material and finish. Okay, so that we've got a bit more information in our bill of materials. But for now, you can just create that bill of materials and just leave it on the page. We'll resize that and format it once we have our full sheet format going. The other thing that you would do once you have a bill of materials is identify which of the parts link to those items. How we do that, again, is pretty straightforward. Under the annotation tab, there's auto balloon. If you hit auto balloon, when you have a view selected, it's going to create balloons for each of your parts. So looking on the properties to the left of the screen, you can see the type or the alignment of those balloons. Okay. There's a box there to ignore multiple instances. So where you've got two of a part, it will ignore them. Okay, so you can leave that on. And insert magnetic lines, that's the line here, which you can access once you've pressed OK. That line controls the position of all those. So if you don't have that line, then you'll just have the individual balloons, which you can drag individually. The magnetic line helps you position them and keep them spaced evenly. You can also change the types of balloons, what they look like, okay, how many numbers they have, or if they're text, or if they're linked to something else. In this case, we've got them linked to the item number in the bill of materials, and that's by default. So press the tick. So you can see here, part number 1, which has selected this edge here, that's linking to the subassembly. So if I click that arrow and drop it up here, it's still on that pivot pin, which is part of the subassembly. Number 6 here, which is on that bolt, if I click and drag that to this part, that's going to change its number. So these are automatically linked for us. You can change the position of the balloons, where they're linked to, by clicking that endpoint and dragging. So if they stay on an edge, it'll be an arrow. If they stay connected to a face, it'll have a round point. So we have instances like this, number 7, where it's a bit hard to tell what that's selected. That's one where you'd want to change, and just to make it really clear, drop that on a face, rather than on an edge, which is sort of, really hard to identify what part that is attached to. All right. Okay, that'll do for today. Last thing you want to do, and probably should have done this a bit earlier, save your drawing. So you may want to start another folder for project 2. You can probably keep it all in the same folder if you want, but just save that drawing. Give it a decent file name, pulley drawings, and save. That means next week we can add to it, come back, edit the sheet format, and do whatever further changes we need to. All right. So good stuff. That's it for today. If you have any questions during the week, you're working on this stuff, just send me an email. Next week we'll divide into groups for the prototyping part of the project as well, and we'll look at some more advanced. We'll get into some more detail with the drawings and how to do configurations in our parts and start to modify them, ready to export in the later weeks. All right, good job.